Once upon a time, in a dark, cold room, there was a boy. Walking, as he saw a piece of paper by the open window. Confused, has no idea what is going on. Due to his jaunty nature, he stumbled and bumped his great head on the floor.
Where am I?
He saw the crumpled paper as if it was the first time, and opened it. Realizing what's going on, listen closely. You are in a critical moment of your journey through time. Your position is covered by this equation. I need you to calculate the rate at which you're moving through time, or else.
What is that noise? It seems like someone is asking for help. Let me see what I can do. Our friend here is having trouble finding the derivative of a function. As we know from our last lesson, we have different derivative rules that help us find the rate of change of functions. We've learned about the power rule, product rule, quotient rule, and many more. But what if we have a function inside another function? That's where the chain rule comes in. The chain rule helps us differentiate composite functions, functions that are nested inside each other. Instead of applying the power rule directly, we must take into account the inner function and the outer function separately. The formula for chain rule is written as the derivative of y with respect to x is equal to the derivative of y with respect to u multiplied by the derivative of u with respect to x, where u is the inner function, meaning it is a function of x, and y is the outer function, meaning it is a function of u. And that's how we use the chain rule. Instead of differentiating everything at once, we break it into steps and multiply the results.
So let's say, hypothetically, you woke up in a strange place in a different time, and the only thing keeping you from going back home is a math problem involving, surprisingly, chain rule, because calculus is beautifully abstract. So in this case, our main function is d of t is equal to 2t plus 1 raised to 5. We use the chain rule and let u be 2t plus 1. And then we differentiate u raised to 5, which is equal to 5u raised to 4 using the power rule. We then differentiate the inner function, which is 2t plus 1. 2 times t raised to 1 minus 1, and then the singular 1 just becomes 0. 1 raised to 0 is 0, so that just becomes 2. Now we apply the chain rule by multiplying the derivative of the outer function by the derivative of the inner function. d prime of t is equal to 5u raised to 4 times 2. Substitute, so that becomes d prime of t equals 5 2t plus 1 raised to 4 times 2. 5 times 2, this and this, equals 10, which gives us our final rate of 10 2t plus 1 raised to 4.
In our given, we have d open parenthesis t close parenthesis is equals to open parenthesis 2t plus 1 close parenthesis raised to 5. This type of function can be derived using the basic differentiation rules, such as constant rule, constant multiple rule, power rule, sum and difference rule, multiplication rule, or division rule. So, we use chain rule to derive this type of function.